Beneath New Zealand lies a continent larger than India. 94% of it is underwater. And for most of modern history, we failed to recognize what it was. But Zealandia is only one of 10 lost worlds hiding beneath oceans, ice sheets, and even populated islands. Some were torn apart. Some were pushed deep into the earth. And at least one may still be waiting for scientists to prove it exists. Number 10. Sahul and the ocean crossing that should not have been possible. In 2012 and again in 2015, archaeologist Chris Clarkson of the University of Queensland climbed back down into a rock shelter called Majidbebe on Mirarr country in Arnhem Land in Australia's Northern Territory. Other researchers had already dug there twice before in 1973 and 1989, and each time had pulled up stone tools old enough to unsettle the accepted timeline of when people first reached Australia. Clarkson's team went back to the same sandstone floor with better instruments, and a harder question, how old precisely was the lowest layer they could actually confirm? The answer took years to pin down. Working with geochronologist Zenobia Jacobs of the University of Wollongong, the team applied optical dating to more than 20,000 individual grains of sand surrounding the artifacts, measuring the last moment each grain had been exposed to sunlight before it was buried. More than 10,000 stone artifacts came out of the lowest layer alone, including ground-edge hatchet heads and seed-grinding stones, among the oldest known anywhere on the planet. The hatchets rank among the earliest known examples of that technology, evidence of remarkable tool-making innovation in Pleistocene Australia. Published in the journal Nature in July 2017, the results placed human occupation of northern Australia at around 65,000 years ago. That early date has been debated, but it remains supported by the original excavation team's analysis. Not 60, not 50, around 65,000. To understand why that number is troubling, you have to understand what it took to get there at all. At the lowest sea levels of the last ice age, Australia, New Guinea, and Tasmania fused into a single landmass geologists call Sahul an unbroken continent, approaching the size of the modern continental United States. But even at that lowest point, a channel of deep, fast-moving open ocean tens of kilometers wide at its narrowest separated the edge of the Asian shelf from Sahul's shore. It never closed. No ice age on record ever dropped the sea far enough to bridge it. Now the discovery becomes genuinely disorienting. Crossing that gap required an open water voyage. From some high points near the coast, distant land may have been visible. From others, it may not have been. Either way, this stands among the earliest strong evidence of human seafaring anywhere on Earth. It implies vessels. Researchers who have modeled the currents involved argue that organized deliberate voyages are more plausible than a single lucky drift. That could mean multiple boats provisioned on purpose, rather than one raft blown off course by accident. It implies people capable of building something that could hold a crew across open water, and either returning home or committing entirely to whatever lay on the far side. None of those vessels survive. A hollowed log or a bound raft of reeds does not last 65,000 years in a tropical climate. We have the landfall. We do not have the boat. If the currents had run only slightly harder, that first crossing might have failed, as most first attempts eventually do. An entire hemisphere's worth of human history could have waited for someone else, sometime else to try again. We can prove they arrived. We cannot prove how. The first sailors in the deep human record left behind everything except the one object that would tell us what carried them across. Number 9. The Gamburtsev Mountains and the range no living person has ever seen. In 1958, a Soviet Antarctic survey team working deep in the continent's interior recorded something unexpected in its seismic readings. The data showed unmistakable signs of a major mountain range buried near the highest point of the East Antarctic ice sheet. The terrain was so remote that for the next 50 years, almost no one could look any closer. The range was named for Grigory Gamburtsev, a Soviet geophysicist, and then it sat there, an anomaly in old data, largely unexamined for half a century. That changed during the International Polar Year of 2007 to 2009, a seven-nation collaboration called the Antarctica's Gamburtsev Province Project flew two ski-equipped aircraft back and forth across the region. Co-led by geophysicist Robin Bell of Columbia University's Lamont Doherty Earth Observatory, the project collected more than 1,200,000 kilometers of radar gravity and magnetic survey lines. The results were published in Nature in 2011 by a team that included Fausto Ferraccioli of the British Antarctic Survey. For the first time, they resolved peaks, rising more than 2,400 meters, and a chain stretching some 1,200 kilometers. It was comparable in scale and drama to the European Alps, yet buried under as much as 3 kilometers of solid ice. The range is flanked by some of the largest subglacial lakes on the continent, sealed bodies of liquid water trapped between rock and ice. Glaciologists also consider the region a potential target in the search for ice more than 1 million years old. If recovered, that ice could preserve an extraordinary climate record that remains unread. A mountain range the size of a major European chain sealed beneath ice thick enough to bury most of the world's skyscrapers several times over, and not one human eye has ever seen it directly. That created a major geological puzzle. The crust underneath the Gamburtsev's part of the East Antarctic Craton is over 1 billion years old and has been relatively stable for much of that time. Ancient, quiet terrain normally has an enormous amount of time to erode. Yet the buried range still preserves sharp, alpine-style valleys and peaks. Geologist Carol Finn of the U.S. Geological Survey, a co-author on the 2011 paper, described untangling the contrast between the old crust and the youthful-looking landscape as one of the hardest parts of the project. Robin Bell compared the range's discovery to opening an ancient tomb and finding something unexpectedly well-preserved inside. The leading explanation involves not one mountain-building event, but several processes stacked across 1 billion years. Ancient rift systems may have been reactivated, uplifting the terrain before rivers and glaciers carved it. Later, the East Antarctic ice sheet helped preserve that landscape beneath the ice. No drill has yet reached the central bedrock of the range itself. Most of the detailed picture comes from radar gravity, magnetic, and seismic measurements made through kilometers of ice. Researchers have also studied glacially transported rocks that may have originated along the range's flanks. The mountains remain physically remote, but the explanation is no longer based on echoes alone. Somewhere beneath the center of East Antarctica, a mountain range as large and dramatic as the Alps has remained sealed in cold and darkness for longer than our species has existed. Its bedrock once stood beneath open skies. Today, however, its central peaks remain hidden from direct human view. Number 8. The Seychelles and the vacation island built on the wrong kind of rock. As early as the 1830s, Charles Darwin was already publishing observations on a strange detail from the granite islands of the Seychelles, adrift in the middle of the Indian Ocean, a detail no one at the time could adequately explain. Decades later, in 1912, Alfred Wegener reached for that same evidence, citing the Seychelles granite as one of his supporting arguments for a new and widely mocked idea called continental drift. It would take another half a century and the full acceptance of plate tectonics before anyone could actually explain what Wegener had only been able to point at. The problem both men had noticed was simple to state, and for more than a century almost impossible to resolve granite forms deep inside continents under enormous pressure over enormous stretches of time. It does not belong on a lonely island thousands of kilometers from the nearest landmass. The modern explanation came from the seafloor itself. In 2008, geophysicist J.S. Collier of the University of Southampton and colleagues published a study in Earth and Planetary Science Letters. Using magnetic anomaly mapping, they placed the Seychelles' separation from India between 63 and 65 million years ago. That was within a geological eye blink of the Deccan Traps eruptions, among the largest volcanic events in the planet's history. The Seychelles Bank is a genuine fragment of continental crust, roughly 44,000 square kilometers in area, built partly from granite, dated to about 750 million years old. That makes it roughly the size of Switzerland, sitting alone in open ocean with nowhere left to call home. Granite islands are extremely unusual in this setting, far from a major continental landmass and surrounded by oceanic crust. For decades before plate tectonics became orthodox science, geologists treated the Seychelles as an anomaly. The alternative that pieces of continental crust could travel across an opening ocean basin sounded absurd until the 1960s made it standard. Then the story turns genuinely strange. In 2013, geologist Trond Torsvik of the University of Oslo proposed that the Seychelles might not be an isolated curiosity at all. They could be part of something much larger, a broken arc of continental fragments associated with Mauritius, extending south toward Mauritius, more than 1,000 kilometers away. In this reconstruction, much of the remaining crust is buried beneath younger volcanic rock and open water. If that reconstruction holds, then the granite tourists walk across on Seychelles beaches today is not a solitary fragment at all. It is one surviving piece of a larger tectonic story that once connected India, Madagascar, and neighboring continental blocks. There is no wall border marker or visible seam on the modern coastline showing where ancient continental crust ends and younger ocean floor begins. Torsvik and his colleagues have argued that more fragments of this kind may be scattered across ocean floors that have never been sampled closely enough for anyone to notice. People fly in every year to lie on that pink granite sand without any way of knowing it. They are resting on an island, but beneath it lies an exposed fragment of continental crust left behind when a much older world broke apart. Number 7. The Kerguelen Plateau, the drowned forest that keeps almost coming back. Between February and April of 1988, the drilling ship Joyd's Resolution sailed out of Fremantle, Australia, carrying scientists from Ocean Drilling Program, Leg 120. Led by researchers, including Renee Schlick and Sherwood Wise, they were bound for one of the most remote stretches of ocean on the planet, the Kerguelen Plateau. This submerged expanse in the far southern Indian Ocean is roughly 2,300 kilometers long, making it one of the largest oceanic plateaus on Earth. Across 5 separate drilling sites, the crew bored down through seafloor sediment and volcanic rock hunting for an explanation of what this enormous underwater feature actually was. What came up from the cores at Site 750 inches, an area called the Raggett Basin, was fossilized wood. Some of it had been charred by ancient fire. The wood was identified as an extinct conifer called Podocarpoxylon and dated to the early Cretaceous more than 100 million years ago. Decades of follow-up surveys, including a second major drilling campaign in 1998 and 1999, added another layer to the picture. Parts of the southern plateau, now sitting roughly 2 kilometers underwater, contain evidence of continental material beneath enormous volumes of volcanic rock. Other portions are dominated by oceanic basalt. Kerguelen is primarily a vast volcanic plateau, but its construction may have incorporated fragments of older continental crust. A second major expedition ocean drilling program, Leg 183, returned in December 1998 and continued into February 1999. It drilled deeper into the Kerguelen Broken Ridge system and confirmed the feature as one of the planet's largest large igneous provinces. The plateau records colossal episodic outpourings of volcanic rock built over tens of millions of years and commonly linked to mantle upwelling. That same work established that Kerguelen once had a twin, a companion fragment called Broken Ridge, still joined to it as recently as 43 million years ago, tore free and drifted north toward Australia, leaving Kerguelen alone in the far south, to keep rising and sinking without it. At times across its history, a stretch of this plateau now buried 2 kilometers down, stood entirely above the waves, an island roughly the size of Great Britain growing forest. What makes this particularly unsettling is that parts of the Kerguelen Plateau have occupied very different elevations through time. Volcanism built sections above the waves. Forests grew. Then, long-term cooling erosion and subsidence carried much of the plateau beneath the ocean. Different blocks did not necessarily move in perfect unison, and the record is incomplete. 1992 scientific paper on its history published in the official proceedings of the drilling program carries the title Subsidence of the Kerguelen Plateau, the Atlantis Concept. Professional geologists reached for the language of myth because the plateau preserves evidence of land where deep ocean exists today. The plateau's isolation is not incidental to the mystery. It sits roughly 4,000 kilometers from the nearest major port in seas, rough enough that research vessels visit only rarely. Nearly everything known about Kerguelen's long history of volcanism, emergence, and subsidence comes from a handful of expeditions spread across 4 decades, not a continuous record. Somewhere inside that 100-million-year history, forests grew on ground that would eventually disappear beneath the sea. Nothing alive there could register the scale of the change or warn the next generation of trees that the soil beneath their roots was only borrowed. Today, in one of the coldest and most isolated reaches of open ocean on the planet, most of the Kerguelen Plateau remains far below the surface. Only its highest islands still rise above the waves. Number 6. The Lomonosov Ridge and the buried mountain range behind 3 overlapping claims. On the 2nd of August 2007, Russian polar explorer and parliamentarian Artur Chilangarov climbed into the submersible Mir-1. He descended 4,261 meters through freezing ice-covered water to the seafloor beneath the North Pole. There, a mechanical arm planted a titanium Russian flag and collected samples associated with a feature little known outside geology, the Lomonosov Ridge. Russian President Vladimir Putin met the returning expedition in person and called its findings central to his country's case. The ridge had first been mapped in real detail by Soviet researchers in 1954 and named for Mikhail Lomonosov, the 18th-century Russian scientist who had theorized something like it might exist. Later, seismic surveys filled in the rest. The ridge runs nearly 1,800 kilometers unbroken, clear across the entire Arctic Ocean basin, rising as much as 3,300 to 3,700 meters, above the surrounding seafloor to within 600 to 1,400 meters of the surface. Its crust measures 20 to 25 kilometers thick several times, the thickness of ordinary oceanic crust and structurally continental rather than volcanic. Geological reconstructions place its separation from the Barents-Kara sea margin of Eurasia through continental rifting at approximately 56 to 53 million years ago, the same event that opened the deep, spreading basin of the modern Eurasian Arctic. The ridge does more than sit there quietly. It acts as a structural spine dividing the Arctic Ocean into two distinct basins. The older Amurasian Basin lies on one side. On the other is the younger Eurasian Basin, where spreading continues along the Gokul Ridge, one of the slowest mid-ocean ridges on Earth. Geologically, the Lomonosov Ridge is the seam between two different chapters of the Arctic's history, fused together across 56 million years of separation. An underwater mountain range, longer than the distance from New York to Los Angeles, built from continental crust, rather than ordinary ocean floor, hidden beneath the shifting ice of the Arctic. At this point, the story stops being purely geological. Under the United Nations Convention on the Law of the Sea, a coastal state may establish rights to seabed beyond 200 nautical miles if scientific evidence shows that the area is a natural prolongation of its continental margin and meets the convention's technical rules. Russia has submitted evidence involving the Lomonosov Ridge. The Kingdom of Denmark has filed a submission through Greenland. Canada has also submitted an Arctic Ocean claim extending toward the North Pole. These submissions overlap across parts of the Central Arctic. They concern sovereign rights to resources on and beneath the seabed, not ownership of the water above it. The United Nations Commission evaluates the scientific and technical limits of each submission, but it does not decide the final boundary between states with overlapping claims. That would require negotiation between the countries themselves. The possibility of future oil, gas, and mineral resources adds economic weight to the argument, although the quantity and recoverability of those resources remain uncertain. None of the three disputes that the ridge is real or that it contains continental crust. The legal question, however, is not simply which modern continent it broke away from. It is whether each claimed area satisfies the rules for an extended continental shelf from a particular coastline. It is a very human argument over seabed that has remained frozen dark and far beyond any shoreline for tens of millions of years. Far below the ice, in deep cold and total darkness, sits a mountain range longer than a cross-country flight. It has never known a human footstep, only the slow movement of water across its peaks instead of wind. And it will remain there largely unmoved long after every flag planted above it and every claim filed for it has been forgotten. Number 5. Mauritia, the buried continent, underneath a million people. In 2013, geologist Trond Torsvik of the University of Oslo's Center for Earth Evolution and Dynamics led a team that collected handfuls of ordinary-looking volcanic sand from beaches on the island of Mauritius in the western Indian Ocean. Laboratory analysis of the zircon crystals mixed into that sand returned ages between roughly 660 million and nearly 2 billion years old. A mineral signature with no business appearing anywhere near an island that is itself only about 9 million years old. The finding, published in Nature Geoscience in 2013, proposed that the zircons had been dragged up from a buried fragment of ancient continental crust directly beneath the island, entrained inside the lava that built Mauritius on top of it. Critics pointed out reasonably that loose beach sand could in theory have blown or washed in from somewhere else entirely. 4 years later, geologist Louis Aschwal of the University of the Witwatersrand worked with Michael Wiedenbeck at the GFC German Research Center for Geosciences in Potsdam. They found anomalous zircons dated between 2.5 and 3 billion years old, locked directly inside solid volcanic rock. The host rock was only 5.7 million years old and could not plausibly have been contaminated by drifting beach sand. The ancient continent beneath Mauritius was not a fluke of beach chemistry. It was real solid and directly underfoot. Torsvik's team traced its origin back further still, identifying it as a sliver of a much older supercontinent called Rodinia, which held nearly all of Earth's landmass together roughly a billion years ago, long before Gondwana or Pangaea existed in any form. By Torsvik's estimate, fragments of Mauritia may lie beneath as much as 10 kilometers of younger volcanic rock and seafloor sediment in places. They are buried so deeply that eruptions carrying ancient zircon grains upward provided some of the first clues that continental crust was there at all. The researchers named it Mauritia. Models describe a region of continental fragments once located between Madagascar and India before their separation around 85 million years ago. Some reconstructions connect those fragments in a broken arc extending north toward the granite islands of the Seychelles. Now consider where Mauritia is hidden. Not like a sunken ship on the open seafloor waiting for a submersible to stumble across it. It lies directly beneath a living populated island. Beneath roads, resorts, sugarcane fields, and more than 1 million people going about an ordinary day. It was buried not only by ocean water but by younger lava flows that helped build the visible inhabited island above it. Louis Ashwall has said publicly that more pieces of ancient continental crust may be scattered across the same region. The ground beneath other islands could therefore conceal fragments of a vanished world with no obvious trace at the surface. Everything currently known about Mauritius' true size and shape remains an estimate reconstructed from zircon grains, geophysical evidence, regional plate models, and a limited number of rock samples rather than anything resembling a complete map. Children build sandcastles on Mauritius today, without knowing that a few extraordinary zircon grains found in the island's sand are older than land plants, older than fish, and older by a staggering margin than complex animal life. Those rare crystals are tiny pieces of evidence from a world buried far below the beach. Number 4. Argoland, the continent that vanished into pieces too small to find. In 2017, geologists Eldert Advocaat and Douwe van Hinsbergen of Utrecht University went looking for a continent they were confident had to exist. Marine magnetic anomalies mapped across the Argo-abyssal plain revealed the history of the margin off northwestern Australia. They showed that a broad region of continental lithosphere rifted away in the late Jurassic, roughly 155 million years ago, and drifted north. Based on the size of the scar it left behind, the missing landmass would have stretched more than 3,000 miles across roughly the width of the continental United States. Advocaat and van Hinsbergen expected to find it largely intact somewhere beneath the islands of Southeast Asia. 7 years of fieldwork followed across Sumatra, Borneo, Java, Sulawesi, Timor, the Andaman Islands, and Myanmar. Advocaat later described the process as working with islands of information scattered through decades of separate national geological surveys. Each used its own maps, dating conventions, and terminology. None had been assembled with every other piece in mind. The researchers never found Argoland as one intact block. Instead, they identified small, badly deformed, disconnected slivers of old continental rock buried under younger geology and scattered across the region. Some of those rocks were far older than the 155 million year rifting event as continental rocks often are. Their ages were not a contradiction. They were clues to the much longer history of the fragments. The pieces eventually got names of their own. They include fragments in southwest Borneo, the Paternoster region, East Java, and South Sulawesi. Others lie in the West Burma block, underlying much of modern Myanmar, and in the Mount Victoria land sequence farther west. Each carried its own structural history and its own collision with Southeast Asia at a different time. These were pieces of a tectonic system that had begun fragmenting long before it finally separated from Australia. The search had stopped going the way anyone expected. The continent that should have existed was not there as one intact block. The study, published online in 2023 and in the 2024 volume of Gondwana Research under the title Finding Argoland, concluded that the fragments separating from Northwest Australia already consisted of multiple ribbon-like continental pieces and intervening ocean basins. The researchers call this archipelago the Argopelago. Its fragmentation had begun long before the final separation from Australia and accelerated around 215 million years ago. It arrived in Southeast Asia not as one coherent landmass but as a collage of fragments. Advocaat and Van Hinsbergen are not new to this kind of search. The same lead researcher, Van Hinsbergen, had previously reconstructed an entirely different vanished landmass, a Greenland-sized world called Greater Adria, found crushed and buried beneath the mountains of southern Europe. Between the two of them, this research group has now located two separate continents that no longer exist in any single coherent standable-on form, one ground into mountain range, the other shattered into splinters, spread across a dozen countries' worth of jungle and coastline. Van Hinsbergen has said directly that without reconstructions like these, geologists would have hardly any real idea what the planet's deep past actually looked like at all. For 7 years, two geologists searched a vast region for a missing world and found only its scattered remains. The fragments were too small, deformed, and widely separated to form anything you could stand on and identify as one intact continent. There is no way to know how many other such wrecks, whole vanished continents broken past recognition, are sitting under our feet in exactly the same condition, simply because no one has yet gone looking with the right question already in mind. Number 3. Greater Adria, the continent ground to nothing under Europe's mountains. For more than 10 years, geologist Douwe van Hinsbergen of Utrecht University worked with colleagues in Oslo and Zurich. They tried to make sense of one of the most tangled geological regions on the planet, the mountains surrounding the Mediterranean. Van Hinsbergen has described the region as a mess with everything curved, broken, and stacked on top of itself. The team used paleomagnetic data from more than 2,300 sites across over 30 countries, stretching from Spain to Iran. These minerals record the orientation of rock at the time they formed. Combined with plate reconstruction software, the data allowed researchers to play Mediterranean history backward across 250 million years. They traced a continental realm called Greater Adria, roughly the size of Greenland, which separated from North Africa around 240 million years ago and moved north. By about 140 million years ago, it sat largely submerged beneath a shallow, warm tropical sea, quietly accumulating limestone on its own drowned surface. The findings were published in Gondwana Research in 2019. 240 million years ago is not simply before the pyramids, before Rome, or before human beings of any kind. It reaches back to the early age of dinosaurs near the dawn of the first true mammals, when many familiar branches of life had only begun to emerge. Then the fate of Greater Adria stops resembling disappearance and starts resembling annihilation. Its plate drifted north for more than 100 million years before converging with Europe. Beginning roughly 100 to 120 million years ago, much of Greater Adria's lithosphere, the rigid crust and upper mantle layer that can be around 100 kilometers thick, was forced beneath Eurasia. Seismic imaging allows geologists to trace parts of those subducted slabs deep into the mantle in some reconstructions, to depths approaching 1,500 kilometers. Sediments and pieces of the upper crust were scraped off, folded, faulted, and lifted into mountain belts, including parts of the Alps, the Apennines, the Balkans, and the ranges of Turkey. Which means the one small strip still associated with the name Adria today, running through parts of Italy, and the Adriatic region preserves part of a much larger tectonic story. Many rocks exposed around the Mediterranean mountains are sediments and crustal fragments derived from Greater Adria and neighboring basins. A traveler on a Croatian coast, a ridge in the Dolomites, or a summit in the Balkans may therefore be standing on material deformed during the destruction of that vanished realm. Geologists can trace portions of the subducted slabs deep into the mantle, using seismic waves farther than any drill has ever reached. Yet only fragments of the former continental realm remain exposed at the surface. The rest is not hidden in the same way as Zealandia or Mauritia. Much of its lithosphere has been pulled into Earth's interior, where it will be recycled over geological time. Number 2. Icelandia, the continent that might not have finished breaking apart. In 2021, Gillian Falger, emeritus professor of geophysics at Durham University, and an international team of colleagues, published a chapter laying out a claim that, if confirmed, would change the geological map of the North Atlantic. Parts of the crust beneath Iceland and the Greenland-Iceland-Faroe Ridge are far thicker than ordinary oceanic crust. The Standard Model attributes that thickness largely to intense volcanism associated with the Mid-Atlantic Ridge and the Iceland Mantle Plume. Falger's team proposed an alternative. Some of the material may include continental crust left behind during the opening of the North Atlantic. An earlier paper in 1977 had raised a related possibility decades before modern surveys could test it in detail. Fowler's team argues the simplest reading of the data is that the unusually thick material under Iceland is not built-up oceanic crust at all. It is continental crust submerged and largely hidden left behind when the North Atlantic tore open roughly 50 million years ago and never fully separated from its neighbors the way geologists have long assumed it did. They call this proposed landmass Icelandia. By their estimate, Icelandia could cover around 600,000 square kilometers, more than twice the area of the United Kingdom. If adjoining regions toward Britain are included in what the team calls Greater Icelandia, the proposed total could approach 1 million square kilometers. The implications reach beyond pure geology. Philip Steinberg, director of Durham University's Center for Borders Research, has noted that nations spend heavily to map their continental shelves. Those surveys can support claims to seabed rights under the same legal framework involved in the Lomonosov Ridge submissions. If Icelandia is real, an entire redrawn map of whose seabed is whose in the North Atlantic could follow directly behind it. This claim runs directly into legitimate scientific doubt. Icelandia is not an established continent. It has not been confirmed by deep drilling or adopted by the wider geological community. The mantle plume model remains the leading explanation for Iceland's volcanic crust, and many researchers are not convinced that hidden continental crust explains the evidence better. Fowler and her co-authors have said plainly that Icelandia still needs to be tested through deep drilling, further geophysical surveys, and zircon dating. Those are the kinds of direct tests that could reveal whether ancient continental material really lies beneath the volcanic pile. What makes this fascinating has nothing to do with whether Icelandia eventually turns out to be real. It is that credentialed geologists are still testing whether the breakup of Pangaea left more continental material in the North Atlantic than conventional maps show. Zealandia also required decades of accumulated mapping, sampling, and geophysical evidence before researchers presented the modern case for treating it as one coherent continent in 2017. Icelandia has not reached that point. No drilling campaign has yet supplied the decisive evidence, and there is no confirmed date for when one will. Icelandia remains in scientific limbo, proposed, debated, and not yet proven. Other fragments of continental crust may still be concealed beneath volcanic plateaus and ocean basins. But until direct evidence arrives, they remain possibilities rather than discoveries. Number 1. Zealandia, the continent that was never actually lost, only never actually seen. In August 2017, the drilling ship Joid's Resolution dropped anchor roughly 1500 kilometers east of Australia and began boring into the floor of the Tasman Sea. Over the following 2 months, 32 scientists from 12 countries worked around the clock in 2 shifts. As part of International Ocean Discovery Program Expedition 371, they drilled 6 sites across a plateau that still does not appear on most everyday maps. They recovered more than 2,500 meters of core, spanning roughly 70 million years of geological history. Some samples came from more than 860 meters beneath the seafloor. The cores included mudstone packed with microscopic shells from warm, shallow seas. They also contained fossil pollen and spores carried from land vegetation, evidence that parts of Zealandia were once much shallower and that some areas stood above sea level. Gerald Dickens of Rice University, one of the expedition's co-chief scientists, noted that Zealandia's ancient geography and climate were dramatically different from what we see today. The cores showed that the continent had not always been as deeply submerged as it is now. 6 months before the drilling voyage set sail, geologist Nick Mortimer of GNS Science and 10 co-authors published a formal argument in GSA Today. They described a coherent region of continental crust, spanning 4.9 million square kilometers. It is larger than India, roughly 2/3 the size of Australia, and satisfies the geological criteria they used to define a continent. Elevated above the surrounding ocean floor. Built from the right kind of rock. Large enough, distinct enough, geologically coherent enough. They gave it a name, Zealandia. 94% of it sits underwater. And this was not found in some unreached trench or unmapped stretch of wilderness. New Zealand is a modern nation of more than 5 million people, its coastlines charted and its waters crossed by ferries, fishing boats, and cargo ships every day. The crossing of Cook Strait between Wellington and Picton passes over a shallow submerged saddle within Zealandia's continental crust, and almost no passenger thinks of it that way. Much of the evidence used to define Zealandia had accumulated over decades in seismic surveys, sonar charts, rock samples, and geological maps. What changed in 2017 was not the sudden appearance of a continent. It was the publication of a unified peer-reviewed case that the entire region should be treated as one. Even after the 2017 paper, the work was not finished. By 2023, researchers had completed a detailed geological map covering the entire submerged continent, incorporating fresh dredge samples from Zealandia's least explored northern reaches. The name itself predates the 2017 paper by more than 2 decades. Geophysicist Bruce Lewandowski coined it in 1995 as a useful label for the broad continental region around New Zealand. 22 years passed between that suggestion and the formal geological case that brought the idea to a much wider audience. There is no international authority that issues a legally or scientifically binding list of continents. Zealandia's status rests on the geological evidence and on how researchers classify that evidence. In all 22 of those years, the rock underneath the Tasman Sea did not change. The region had already existed as a large, coherent body of continental crust for tens of millions of years, whether or not people agreed to call it a continent. Being named is not the same thing as coming into existence. It is the moment a scientific description finally catches up with what has been there all along. Which leaves one question worth sitting with: after the numbers stop, the map closes, and the ferry finishes its crossing. How much of the world remains familiar only because we have inherited an old way of labeling it? Zealandia was not unknown in every geological sense. Its islands, plateaus, and continental rocks had been studied for generations. What took time was recognizing those scattered observations as parts of one coherent whole. 94% submerged, hidden in plain sight, waiting for the evidence to be assembled into the right question. If you want to see more videos like this, click the video on screen now and make sure to subscribe.